Hello students, and welcome back to Shodof's classes on graphs and on graphing rational functions. Now, what is a rational function? A function, let's define a rational function. A function obtained by dividing polynomial by another polynomial is called a rational function. Right, now let's write some properties that rational function. Property number 1, properties 1, a function defined by 1 by x is called the reciprocal function, or a rectangular hyperbola. Right, now the second would be about the symmetry of the graph. Since fx is an odd function, it is symmetric. About the origin and they are on opposite quadrants. Right? So we'll come to number 3. Is based on observation that as x tends to 0, the limit x tends to 0, fx will be towards positive infinity. This is positive infinity as x tends to 0. So as x tends to 0, as x tends to 0, y tends to positive infinity and 0 plus, and as x tends to 0 minus, x here as we see, as x tends to 0 minus, in fact, let me just put my arrows correctly so that you can understand what is going on. This is my right. Let me just rub that part out so that I don't need to draw that anymore. Alright. So, in fact, I want to rub this out as well, because it's already very crowded here. In fact, let's just write. Fine. Now, as x tends to 0 positive, as x tends to 0 positive, f of x tends to positive infinity. Now look at the graph here. Now as x is tending to positive infinity, this is positive infinity, this is positive infinity and this is negative infinity. These are the values of y, obviously, and these are the values of x. So you can see that as you grow closer and closer to 0, as you go closer and closer to 0, the value of fx or y will tend closer and closer to positive infinity. Although positive infinity is not a real number, we just symbolically assume that it is tending towards positive infinity. And as you go towards the negative side of 0, as you approach 0 from the negative side, we can see that this will tend to the negative infinity, right? So let's just write that down. Limit x tends to 0 positive, f of x is equals to positive infinity, and limit x tends to 0 negative, f of x is equal to negative infinity. Also, just note one thing, this is one part and this is as x tends to infinity or plus minus infinity, f of x tends to 0. Right. Now as you go towards infinity on the x-axis, the y-axis, the value of the y-axis will tend to 0. This is y, which is decreasing and decreasing. So just note that if x here is a decreasing function, and it will go down and down to 0. As you approach to infinity or positive infinity or negative infinity, even here this is negative infinity on the x-axis, so the value of y will tend to 0. That's what they're trying to say. Now let's write the domain and the range of fx. Just write it here roughly. Domain fx equals to real numbers minus 0, since it is undefined for 0, since anything by 0 is undefined, and the range is r minus 0, since, just write this out, since 1 is reduced to 0 only when x tends to infinity, otherwise it won't, no number how big it is, it won't reduce 1 to 0 except infinity, which is not a real number, Okay, I guess that's it for this video. We'll be generalizing functions of the form 1 by x squared in the next video. Thank you for watching.